Hello friends, good evening. My name is Rohit Lala and today I am going to cover one variable regression model, multivariable regression model, problems related to regression models such as autocorrelation, multicollinearity and heteroscedasticity. So let's start our session. So obviously regression model, before discussing regression model, I would like to discuss correlation. If the two series or two variables move in same direction or maybe move in inverse direction, there can be a correlation. So if there is a correlation, you can draw a scatter plot, and after scatter plot you can draw a regression line that help us to predict the future variables. Now regression analysis is a tool which can help us to predict the dependent variable. Now first, before discussing about dependent and independent variable, we should know the cause and effect relationship. In other words, like there is two variables, one is independent variable. The movement is not controlled by anyone, but yes, independent variables movement would lead to change in dependent variables movement, and that's why you can say there is a cause and effect relationship developed between two variables. Now we try to discuss something more advanced by taking an old school example. Now if in one scale I am having a crop yield and on other hand I have a rainfall in centimeter. So if I just wanted to see in a cross section data, more the rainfall, more the crop yield would be, whereas less the rainfall, less the crop yield would be. So now here you can say the rainfall is independent variable, whereas the crop yield is considered as a dependent variable. Moving one step ahead, there are different terminologies that we use. Many research papers, due to avoidance of plagiarism or maybe due to any other reason, they try to write different synonyms of it. So yes, dependent variable, the Y variable, has synonyms such as explained variable, predicted variable, regressed variable, response variable, endogenous variable, outcome variable, controlled variable. Whereas independent variable has synonyms such as explanatory variable, predictor, regressor, stimulus, exogenous variable, covariate variable and control variable. Moving one step ahead, this is our regression equation. So yes, obviously first we need to know this y is our dependent variable and this x is our independent variable. In other words, change in this variable would lead to change in this variable. Moving one more step ahead, this is alpha. Alpha is constant, whereas beta is also a constant. I will explain it in a later slides, but yes, there is one more thing here. This is our error term. So step by step we will understand each of them. So first I have explained you dependent and independent variable. Now I am discussing alpha, that is our intercept. So alpha is nothing. When our value of x is 0, the value would be something of y, and that is our intercept. In my simple terms, you can say a starting point or initial point of a regression model is known as intercept. Moving one step ahead, slope. Slope is nothing. When you change one unit of x would lead to change or beta change amount in y. If I just wanted to show in a graphical analysis, just see here, this is my regression line. If I change, this is our x1 and maybe y is 2, and if I am just taking 1 unit change, and here this change is due to this slope line, and this is our beta. Yes, in equation you can see here yi is equal to alpha plus beta xi plus error. So here when you keep the values of x, this much change would be needed in y variable. Moving one step ahead, this is our multiple regression model. Yes, in picture you can see it's an extended love story. Here you have more than one independent variable. and that would lead to change in y. But yes, remember, if I just want to make a memory for you, you have seen a Kapil Sharma's movie Kis Kis Ko Pyar Karo. So all the three wives were not in a same floor. They were given one cocktail tower and all of them was there in a different floors. The same is applied here. When you interpret this regression model, you need to keep other things constant. So yes, y is again a dependent variable, x1 is independent variable 1, x2 is independent variable 2. Again here alpha and beta would be there, and yes, error would always be there, because in love story some error is always there, or in other words villain is always there. So in my simple terms, error is unexplained variance, which we will see in our further slides. Yes, more important part, R square. R square is nothing. When you apply any regression model, the output would have R square. R square is known as explained variance. The proportion of variation has been explained by the regression model. In my simple terms, the change in y variable due to change in x variable, the percentage amount would be described there. I will show you in this graph. So this is our y variable. Suppose now this x and y is there. This is my regression line and this is my real point. This is my y point. And if I am considering y bar, this is my y bar. So if I am just taking average of it, so you can see my point is so far from the real value. But if I am drawing a regression line, it is somewhere here. This is my point of y cap. Now this much part is explained variance. You can say yes, this much part is covered by regression model. But yes, this much part is unexplained. You can say residue. And this whole part is known as a total part. You can say TSS, total sum of squares. Now always remember, when you find out R square, it would be always 1 minus RSS by TSS. I would say R square, the better the R square, the better the model. जितना पास आपका रिग्रेशन लाइन होगा, R square उतना ज़्यादा आएगा, और जितना ज़्यादा R square आपका, उतना ज़्यादा predictive model. Moving one step ahead, what are the problems associated with R square? So always remember the problem of spurious regression program. Before explaining spurious regression, I should explain spurious correlation. एक example देता हूँ. My daughter Gunjan, every year her age is increasing, and Rajkot's temperature is also increasing every year. So if I just run a correlation, yes, it would give me somewhat positive correlation. But yes, it's a meaningless correlation. It does not have any meaning to it. So yes, this kind of spurious thing can also be determined by R square. If your regression has 0.99 something R square, you can say this kind of thing is not acceptable. It's a spurious R square. Moving towards second step, high correlation between two variables. Yes, it would cause a problem of multicollinearity, because this both would impact y and that would have more explained variable. Correlation always does not imply causality, as I always say. See, here the correlation was there, but causality was not there. Change in temperature was not because of Gunjan's age, nor Gunjan's age was affecting the temperature of city. Yes, two types of data are there: cross-sectional data and time series data. I would discuss this very simply, very fast. Time series data is at one point of time you are one variable is collected at different point of time is known as time series data. Whereas at one point of time you are collecting it from different variables or entities. This kind of data is known as cross-sectional data. So when you run the regression on both of them, this would have some different R square. I always say time series data में R square कम होता है, whereas cross-sectional में ज़्यादा होता है. More important, improper functional form of equation. रिग्रेशन के बहुत सारे फॉर्म्स हैं. If you adopt a wrong functional form, it would give lucid answer, non-acceptable answer. Yes, R square are not comparable. If I just take different forms of R square, like for example, this is one example, yi is equal to alpha plus beta x plus error. And if I am just taking a regression model is equal to yi is equal to alpha plus beta log x plus error, this both are square of same variable, but yes, I have taken log of x and here there is x. You cannot compare it. This both are totally different. They have different sense. Moving one step ahead, error. Error को अगर simplify कर दूँ तो error means unexplained variance. Error means unexplained variance. In our model, this part is not explained. This is known as error. Yes, error have different synonyms. You can say stochastic variables. You can say random variable. Yes, white noise is commonly used in time series data. Or you can say non-systematic data. Moving one step ahead, why this error exists in a model? Yes, the first reason is vagueness of theory. See, not every theory is covered. Some part is not studied by us. I would always give the example of COVID. COVID में बहुत regression run की है, but everything was not known to us. Due to some unavailability of data, this thing happens. Due to core variable and peripheral variable. हाँ, main variable और side variables की वजह से भी होता है. Yes, due to human behavior. We all are human being. We all have random behavior. Due to poor proxy variable. If we are doing kind of a study, like we are trying to study latent variables or maybe any other thing, and we try to give a proxy variables to capture the data, and if we are not having the proper questionnaire or maybe the proxy variable does not capture it properly, then also there is a chance of error occurring. Yes, principle of parsimony. Yes, this is more important. Principle of parsimony को अगर simple words में कहूँ तो less is better. Select variables कम करो, but उससे अगर ज़्यादा R square आता है, उससे better model बनता है, go with it. So yes, due to that also you can say error is there. And more important, wrong functional form. If your model asks for curve linear things and you are applying linear regression, then also the error can occur. More important thing of the day, there are some assumptions that we need to apply before running a regression model. The first thing, your alpha and beta, or in my simple terms, parameters should be in a linear form. In my simple terms, you should not have alpha square or beta square. You should not have alpha by 2 or maybe beta by 2 or any other form, beta alpha raised to e. You cannot have it. You should have this form only. The second thing, this is applicable in multiple regression. Like if you have model yi is equal to alpha plus beta x1 plus beta x2 plus error. So yes, if this both variable should not correlate, otherwise joint effect would be there. And this problem is known as multicollinearity. More important, your variable should not also correlate with error. Otherwise error would have expanding or you can say it would affect your y variable. Moving towards more important point, your error term should not have autocorrelation. This all things we will see it in a further slides. Yes, mean of the errors would be always 0 because when we are passing it, naturally we are passing a least square method. So mean of this would always be 0. Yes, error term should be constant. In other words, residual should not have a heteroscedastic characteristics. You can see here, if I just draw a normal distribution, it is becoming bigger and bigger. So this kind of regression model is not applicable. There should be a homoscedastic data. More important, your error or residual should be normally distributed. We all we will check all the assumptions of it one by one in EViews. Yes, this is again important. You can note down this. What are the good features of good regression model? The first thing, higher the value of R square, you can say better the model. Moreover, R square should be more than 60% in cross-sectional data. Yes, if your significant variables, when we are applying variables, your X variables should be having a t-test should be performed and they should give a significant result. All the variables should jointly applied a F test and they should also be significant there. More important, your residuals should not be autocorrelated. These are all different tests. DW statistic we have to see. We have to apply Bruch-Godfrey serial correlation test, or you can say LM test. More important, variance of the residual should be homoscedastic. Most of the time we are applying Bruch-Pagan-Godfrey test or White test to check whether our data is homoscedastic or not. And more important, Jerk-Bera statistics is applied to see whether your residuals are normally distributed or not. So if these conditions or if these things are there, your model is good. So let's see one by one, but yes, this is my guru mantra. Always remember, we have to go with hypothesis testing. So you have two hypotheses, null and alternate hypothesis. If p-value is, you can say, less than 0.05, you are rejecting null hypothesis, you are going with alternate hypothesis. But yes, if reverse case is there, if p-value is greater than 0.05, you are going with null hypothesis and rejecting the alternate hypothesis. Here only I will give one of the important message. You have to see whether the coefficients are there. Your p-value should be less than 0.05. And if you are checking residuals, your p-value should be greater than 0.05. So this thing you need to remember. Yes, more important theory concept. What are the uses of regression? So as I said, it is used in a predictive modeling. Many times you are also doing a trend analysis. Many times you are doing a causal analysis. Sometimes you are also using for forecasting. So at the end, in every field, maybe finance, economics, social science and engineering, regression is very common and it's used most of the places. So now we will have a hands-on on regression model in our next video. Just download the data by scanning the barcode. Thank you. We will meet in our next video.